2.6 solving log equations. If it's to the first degree, you should only get one solution. When we are solving logs, our job is to condense them into a single log, and then we're trying to change them into an exponential equation like we did on the lesson above to solve it like we normally would in algebra. Okay, so we've got to take care of any multiplication times a log because that is that power property that we've learned about. So I'm going to move the 4 behind the 2, and this would be log base 6 of 6x. I don't know why they put parentheses. I don't really like them, honestly. Plus log base 6 of 2 to the 4th power. What would that be? 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so that's the first step. Then, since we have addition, we want to combine these logs into a single log with multiplication. So we'll have 6x times 16. 6 times 16 is 96. So we'll have log base 6 of 96x. And then our last step is to convert it. This is our base. This is our power. 6 to the 0 power should equal 96x. What is anything to the 0 power? 1. Solve for x. All you have to do is divide by 96. And so x is 1 over 96. Might get some funky answers on these. Okay. Number 2, the only difference is we have subtraction. So again, scan out any multiplication. I see a 4 times my log, so we got to take care of that first. So this is really 3 to the 4th power. Have the log base 2 of 2x minus log base 2 of 3 to the 4th power, which is what, 81, equaling 1. Now we have subtraction, so let's combine them into a single log, base 2 with division, 2x divided by 81. Okay, I don't think 2 over 81 simplifies nicely because 81 is odd, so we'll just leave it. Let's convert this into an exponential equation. Our base is 2 to the 1st power would equal 2x over 81. 2 to the 1st power is 2. You could look at this as a proportion, or you could look at it as I need to get this x by itself, so I'm going to multiply by this denominator or get rid of the division. 8 times 2 is 16, 1 times 2 is 2, so 162 equals 2x, and then divide by 2. 16 divided by 2 is 8, 2 divided by 2 is 1. We're back to 81. So pretty simple. Why don't you go ahead and pause and try number 3. And you should have gotten 6/5 as your answer. If you didn't or have any questions, please let me know. We've got one more page of this. These 3 problems all have logs with the 2nd degree, and you'll see once we put them together, you'll see that happening. But it gets 2 solutions. Make sure you're checking for extraneous solutions. Remember, extraneous are these extra answers. They look like they should work, but when we plug them in, they don't work. And all you're really checking for is that a log, I'll put cannot be negative. A log cannot be negative, and what I mean by that is, like, if I had log of negative 10. If I tried figuring out what this equals, I know it's a common log with a base of 10, I would say 10 to what power, right? 10 to what power is negative 10? Well, 10 to the 1st power is 10. 10 to the 0 power is 1. 10 to the negative 1st power doesn't make it negative. That actually just flips it, makes it 1 over 10. And so there's no way to ever have a negative here. So that's when the answer is not going to work. Okay? So at number 4, we need to combine these 2 logs together. There's subtraction between them. So this will be log with a base of 2 of 3x squared plus 4 divided by 2x plus 6 equaling 3. I would just leave it like this, and let's go ahead and convert it into an exponential equation. It would be a base of 2 to the third power equals 3x squared plus 4 over 2x plus 6. 2 cubed is 8. This is 8 over 1, so you could cross multiply, or I want to multiply by this denominator to get rid of it. I'm going to distribute the 8. 8 times 2x is 16x. 8 times 6 is 48. Equals my numerator, 3x squared plus 4. So do you see how we have created a quadratic equation where x is being squared, and when we solve quadratics, the best thing or the fastest thing to do would be able to factor it, and remember we have to get it set equal to 0. So I always want to keep my x squared term positive, so I'll leave the 3x squared where it's at. I'm going to subtract the 16x over. Now it's negative 16x, and I'm going to subtract the 48 over. And that's 4 minus 48, which is negative 44. Okay, can I take a 3 out? No, I cannot. So at this point, you might want to do quadratic formula. I still personally would like to try to factor. Remember, when this a value is a number other than 1, you have to do slide and divide. So I'm going to drop the 3 off. 3 times negative 44 is negative 132. And so I'm trying to figure out what two numbers multiply to make negative 132 and add to make negative 16. Ooh. I know since I'm multiplying to get a negative, I need one of each sign. And I know I need more negatives. So I would just start trying to figure out 132 divided by stuff. I kind of even feel like 16 is a factor. Nope. 12 and 11, that doesn't help. They're only 1 away, so that's too big. I need to try smaller. No, not 8. 6. 6 and 22. I like it. Because 22 and 6, if I subtract those numbers, that's a difference of 16. I need it to be negative 16, so I would want that bigger number, 22, to be the negative, and then the positive number to be 6, right? So if I foiled this, that would be x squared minus 22x plus 6x, which is negative 16x. 6 times negative 22 is negative 132. It's like a bad infomercial, but wait, there's more. Don't forget to go back and divide by your a, your 3, because this is kind of cheating the system, but we got to go back and undo what we did. 6 divided by 3 is 2. 22 divided by 3 doesn't happen evenly, so when that happens, we float that 3 back up in front. 3x minus 22. But this is all set equal to 0, so then you have to take each factor and get an actual answer. What number plus 2 would equal 0? Negative 2. You're subtracting the 2 over. What number times 3 minus 22 would be 0? Well, you'd add 22 over and divide by 3, so it'd be 22 thirds. Here's all you need to check, so don't freak out. I know this was a lengthy one. We need to see if these answers both really work. We got an answer of a negative 2. Let's look. Plugging in a negative 2 here and squaring it, that's going to result in a positive, so that's good. But look what happens here. 2 times negative 2 is negative 4. We have to check further. Is negative 4 plus 6 going to result in a positive? Yes. So that's good. You don't even have to check the positive answer. It'll work, unless you just want to, but it'll work. All you're trying to make sure is that you don't end up with a negative out of this piece or this piece, because that's a problem. So you get those two answers. All right, number 5, we're going to put two logs together that have a common base of 7. And they have addition between the logs. So this will become log base 7 of 4x minus 3 times 3x minus 5. Rewrite this. This would be 7 to the 0 power. And then let's go ahead and FOIL this because it's going to equal this product. Let's FOIL. 4x times 3x is 12x squared. 4x times negative 5 is negative 20x. Negative 3 times 3x is negative 9x. And negative 3 times negative 5 is positive 15. 7 to the 0 power is 1. Negative 20x minus 9 more would be negative 29x plus 15. Subtract your 1 over. So I get 0 equals 12x squared minus 29x plus 14. Man, I don't remember these being so not fun. Thought they all factored pretty good. Okay, so here you could do quadratic formula, or I'm going to try to factor again. I've got my a value of 12 times 14. $168. Okay, this one I need to multiply to get a positive. So they could both be positive, or they're going to both have to be negative because I need it to combine to make a negative 29. So let's start seeing what 168 could divide by. 4 and 42. No, because actually you're going to be adding the numbers this time because they'll both be the same negative sign. So I need to make a bigger number. 168 divided by 6. 6 and 28 is 34. I'm getting there. 168 divided by 8. Ooh, 8 and 21. I like it because those combine to make 29. I just have to make them both be negative. Okay, but go back and divide by 12. With these, you have to simplify the fractions first. So 8/12, they can both be divided by 4. 8 divided by 4 is 2, and 12 divided by 4 is 3. And then this, they can both get divided by 3. 21 divided by 3 is 7. 12 divided by 3 is 4. Okay, so you could go ahead and move the 3 up and have that, move the 4 up and have that. But what minus 2/3 would make this factor equal 0? It would just be the opposite sign of 2/3. And what about this one? Positive 7/4. 7/4 minus 7/4 would make 0. So there's faster ways to get the job done. And now looking up here, if I have 4 times 2/3, that would be 8/3 minus 3. Does that work? No. So you could simply plug it in exactly like you see it, of having 4 times, what do we say, 2/3 minus 3. That gets a negative, so that one's out. 7/4, so 4 times 7/4. 4s are going to cancel, that's 7. 7 minus 3 is good. And 3 times 7/4 is going to be 21/4 minus 5. That'll be that quarter. So that's good. So we actually get an extraneous answer of 2/3. Our only answer in this case is the 7/4. Okay, why don't you pause and try the last one. The good news is this one wasn't as hard to factor. It was not a slide and divide because our a value in front of x squared was just 1. Should have gotten your factors, and then your answers are -2 and 34, but I'm kind of worried about this negative, so let's check. If I plug in -2, -2 squared is +4, which is good, but 4 minus 4 makes 0. This is something we hadn't talked about yet. If I have log base 2 of 0 supposed to equal something, let's see if that can be evaluated. 2 to some power needs to be 0. Well, 2 to the first power is going to give me 2. That didn't work. 2 to the 0 power is going to give me 1. That doesn't work. 2 to the negative first power just flips it to be 1/2. That doesn't work. So it looks like you can't have anything with a log of 0 as well. And if I happen to do change of base to check, I could do log of 0 divided by log of 2. There's an error. So we also need to add that your log cannot be negative or 0. So this -2 answer is extraneous. But the 34 should be fine, because that'll get big number minus something smaller, that'll get big, and that's all positive. So you get one answer of 34.